Okay, so let's now continue. Now I would like to add an additional part to this network. And here I have, okay, I don't have here, but I have it here in the layer manager. I have the pressure pipeline layer that I will turn on. Okay, so now we will a little bit repeat what we talked about yesterday. We will draw one additional part of the network, and we will set up a reservoir, a pump, and this will be a pipeline from the pump to the tank. To convert this to, because this is just plain 2D polyline, I will again use conversion of CAD elements. We will use the same DTM as yesterday. The center line will be 1.5 meters below the terrain. We can use the labels. I will use the same labels as we have currently in the drawing. And I will select this polyline here and convert it to intelligent Urbano topology. Okay, let's now draw the profile for this new part of the network. I will use the same profile configuration. Let's go from node to node. I will go from this node here through this node here, all up to the last node of the system. Okay, let's now place this here. I will again use the extension and put it 50 above this one, like this. And here you see that for this part, from the water tank to the last node, we have the piezometric lines, we have everything calculated, and here you see that we don't have anything defined yet except for this center line elevation on a constant depth below terrain. Let's now first define the pipes. I will set the same pipe diameter that we have here, and to do that, I will open the function for setting of the pipes, and here I will select this array like this, and then I will use this match properties, this really nice option where you can select the pipe from the drawing, like let's say this one here is 355, and the software selected that pipe here. And now when you click save, this pipe, the same that is here, will be applied here. So we set the pipe now. Let's continue. I would like now to show you the dynamic model of Urbano. So I will split my screen now so we can simultaneously see both plan and the profile. So this is this part here. And you can see that we have these nodes on a pretty high distance, and this pipeline is not following the terrain as good as it can. So I will now insert some new nodes. You can insert new nodes in plan or in profile. Now I will show you both ways. First of all, let's go to Urbano layout, and to insert new node, I will use this interactive function. This is really nice function because it allows you to edit nodes or sections. If you click on a node, you can change the type of the node, you can label it, you can move it, you can delete it, you can rename it. Or if you click on a section, you can add new node on a section, you can label it, you can delete it, or you can rename it. We would like to add a new node on this section, which is this section here. So let's click here, and now you can see that you can add a new node anywhere, or if you press Control button on your keyboard, you will be locked to that section. So let's click, for example, here, and you will see the software automatically inserted the new node here. So now this section is split into two sections, and here we have one new node here. Also, we can add new nodes directly in the profile. So let's check that now. Let's go to profile ribbon, and let's use edit nodes. And here I will go to insert. You can also move or delete nodes directly in the profile. I will go to insert, and here I will add some new nodes. So for example, let's add one new node here. Let's add one new node here, maybe here as well, or here. Let's add one new node here. Okay. And now you see the new nodes automatically appearing in the profile and in the plan as well. So you can see how they are called some PN, so that you can recognize the new ones that have been added. And you can see the same nodes in the profile as well. Okay, let's now rename this new array that we defined. So let's go to editing, edit of the arrays. Let's go to rename automatically, and let's select this one here. I will give it some prefix. I don't know, let's put a prefix T, apply. So it will be a T1. Okay, let's now also rename the nodes. Okay, I will use the function for renaming by arrays. So I will select this array, but also this array as well. If you remember yesterday, if I select just this array here, it will be renamed, all the nodes will be renamed. But I don't want this node to be renamed to, it will be T something, the last node of the T array. This is why we have this sorting. So if I say A1 is in front of T1, then this one will be main. So let's say as a prefix, again, just like yesterday, I will use the name of the array like this. And now if we click on apply, you see this one will rename A11, and all the other ones are now T11, T12, T13, and so on. Also, you see that now this, again, these nodes are, these labels are intersecting with the elements. So we can also rerun automatic label reposition for the entire network. Let's run it. Additional 7 labels are automatically repositioned. So now you can see how it looks automatically much, much better. Okay, and let's also rename the sections. So let's go to renaming of the sections. Let's select this array here, and let's use the pattern. If you remember from yesterday, monkey 5 is for counter. So I will say, let's say T with the suffix monkey 5. So it will go from T1 to T10. And let's click apply. Okay, so we define now the new nodes, but you see that the pipe is still on the same position. The pipe didn't move, we just have new nodes. So now that we have new nodes, we can go again to input data, invert elevation, and let's set now for this array here, this new one here, let's set that the center line is again 1.5 meter below the terrain for each node. Let's click save. And now you will see that now we have our pipe that is following our terrain much, much better. Okay, so we defined that. You can see that also we didn't set the trenches and the top layers, so we can set up that as well. Let's repeat from yesterday. Let's go to trenches. Let's select this array. Let's set the same trench as yesterday. Let's click save. Okay, let's go to setting of the upper layer. So input data, upper layer. I will use again the soil of 20 centimeters. Let's select this array and let's click save. Okay, and now we have everything defined. Okay, so now as we see here, we have to also define reservoir, pump, and that's it. So let's now go to Hydra panel, hydraulic node equipment. Let's select the first node in this system, this one here, and let's set it up to be a reservoir. And let's click apply. You see that a custom node appears in plan and also here in profile as well. Let's also set a water tank, a pump. So let's go to hydraulic node equipment. Let's select this node here, and let's set this up to be a pump. For a pump, you can use a pump curve or pump power. I will use a pump curve, but we have to define the pump curve, so we will do that now. Let's click apply, and you see that the pump is set, and again you see the custom block appearing in plan and also appearing in the profile as well. Okay, so now that this is defined, we can switch back to having just one view. So let's do it like this. And let's now turn off this helping layer. We don't need this anymore because we converted everything to Urbano. So let's turn off pressure pipeline. Okay, let's now define a pump curve. How to define a pump curve? So we have to know a flow and the difference between the starting and ending pumping elevation. So let's check this. Let's open the node geometry and let's select this node here from the pump to the tank. Okay, and this is the physical difference in elevation. So if we open the calculator, we will have the 103.36 minus 36.56. This is 66.8. But also, if you remember, inside of our water tank, we defined the starting initial water level to be 3 meters. So I like to include those 3 meters in the pumping elevation as well. So the pumping elevation will be around 70 meters. And also what flow we are going to pump. So as you remember, we have the flows already calculated. This is the 76.14, but if you remember, this is with firefighting demand. So it's up to you to define a pump curve. So define curves and patterns. Let's define here. You click just like for defining a new catalog of pipes or manholes or anything. Create a new group. You can give it a name. I will call it pump curve. Then choose here the type of the curve. It will be a pump curve, and then create a new item. Here it is, and give it a name. I will call it, for example, pump 1. And now you click here to set curve data, and here you can define the flow and the head. This is just like in EPANET. Basically, you can define 1-point pump curve, 3-point pump curve, or multiple point pump curve. I will keep it simple, and I will say, okay, our flow without the firefighting demand is 66.14, and our pumping head is 69.8. Of course, you can round this number or define your own pump curve. This is just for this example. You have to click here to add. And now you can see that the software is, so this is the working point of a pump, but the software is also extrapolating all up to flow of 0 to the head of 0. So this is the pump curve, and this whole range of flows is covered now. Okay, let's click OK. Let's click OK. Let's now go to network element data. This is a function where you can see all the set network elements in the drawing. So we have a reservoir, and you can check all the data for those elements. So reservoir, we have a tank, we have a pump, and we have one pressure reducing valve. For the pump, so you don't have to go again to hydraulic node equipment because the equipment is already set. We have a pump already defined. So you can just go to network elements data, and for already set pump, you can set the pump curve, for example, to pump 1. And let's click save. Okay, let's now calculate this. So let's open our hydraulic calculation. Okay, so let's go to hydraulic calculation. Again, we can choose according to which scenario. I will leave this summer plus fire 1. Let's click calculate. Let's click save. Okay, and now you can see how we have calculated this part of the network as well. So we have our pump, adding the pressure to our network, and here we are to our water tank that we had from before. Now let's also define one time pattern. So let's go to the same function, define curves and patterns. Here, let's define a time pattern. Let's add a new catalog group. Let's call it time pattern. And let's create one new time pattern. Okay, let's call it people. Under geometry data, we can define, by default, it's 24-hour, but you can also increase the number of hours or decrease the number of hours and set any number of hours. We will define one 24-hour time pattern. So, for example, during the night, let's start with smaller values. Let's say 0.5, 0.6, 0.7, I don't know, 0.8, 0.9, 1, I don't know, let's go now to 1.1, 1.2. Basically, so now let's say that this is a smaller town. So during the night, we have smaller values. And now during the day, when people go to job, the number is increasing. So basically, we are defining maximum peak factors. Okay, now maybe let's reduce it back to 1.1, then maybe 1, 1.1, 1.2, 1.3. Basically, you define it like you think it is applicable for the area where you are designing the network. And now let's say we have our peak flow of the day. Let's say at this point of the day, people will come home from work and I don't know, have lunch and so on. And this is maybe our peak flow. So 17th hour of the time pattern, which is from 4 to 5 p.m. And now I will start dropping, let's say 1.4, then maybe 1.3, again 1.3, 1.2, 1, and let's finish it with 0.8 and 0.6. So this will be our time pattern for this network, for the people, and let's say for the tourists. And let's also create one additional time pattern, and let's call it fire. I will call it fire, and I will set one firefighting demand during these same hours, that we have our peak flow, and I will just say 1. So from 4 to 6 p.m., we will have one firefighting demand lasting for 2 hours. So during our peak flow. Let's click OK. Let's click OK. Let's now set this defined patterns to our water demands. So we are opening back our dialog for water demands, and let's go here to people. And here you can see that we previously, to size our network, we already defined our coefficient of variation per hour. So be careful. Don't just add now this time pattern here. So under pattern, I will select pattern. I will select people, because now this pattern will multiply these values here. So you will just be multiplying it again with the peak hourly factor. So we have to set this coefficient back to 1. So let's again select the same parts of the network. You can also create some selection sets, so you don't have to repeat this procedure of selection all the time. So here I will switch this back to 1. You see now it's 0.4, but if I write it, now it's 0.27. So we reduced this back to 1 because now we would like to have a time simulation with this time pattern. Let's repeat this for the tourists. So let's assign the same pattern, people, and let's repeat the procedure. So this, and this will have coefficient of variation per hour 1. So now it's 44. Let's write it. Now is 0.29. For the industry, let's say that this industry is using this 6 liters per second during the all 24 hours of the day, so I will not be setting the pattern. And for the firefighting demands, let's set here fire pattern. And for fire 2, we can also set the fire pattern. Let's click close. And let's now go to hydraulic calculation. So let's go to hydraulic calculation. And here now we will go to options and we will switch the total duration from 0 to 24. So we will do simple time simulation lasting 24 hours. Let's click calculate. And now you will see that we will have much more results than before. We have 32 sets of results. So not just 24, because something is also happening in the between hours. And now we will analyze what. So let's save this results. We calculated according to summer plus fire 1 scenario. So we have just one firefighting demand in this node. Okay, so here you can now check all the values, and you can, with these arrows, you can go through time. So midnight, 1 o'clock, 2 o'clock, 3 o'clock, or you can move with this drop-down list to a certain point of a day. Let's say, let's switch to our 4 o'clock where we have our peak flow. So you see 7614, our peak flow, and also you can use your selection options. So let's select maybe just this section here. And here you can see that this is the flow of 1038 with our firefighting demand. Also, you can switch to a time preview for that section. And now you can see for all the periods of the day that at these points here, we have our flows of 1038. So basically during the whole day, we have very, very small flows, but during these 2 peak hours, we have much bigger flows and much bigger velocities. But the best way to analyze always these time results are by using the graphs. So let's switch to graphs. And now here you can select any data that you would like to analyze, and you can do it 2 times. So for data 1 and data 2. For example, let's select this node here where we have our water tank. And now you can see that why we have these multiple results, not just 24, because as you remember, our water level is starting from 3, it's rising until it reaches 6, and then the water tank is full. Now here for velocity, let's also select this section right after the pump. And now here you can see that when the water in the water tank reaches the maximum level, which is 6, the pump closes. So the pump closes, the velocity after the pump is 0. And this is constantly turning on or off because we didn't define any rules when the pump to close and when the pump to open. So the software is automatically turning on and turning off the pump when the water level is it reaches maximum water level. So what we can do now, let's say we can go to network elements data, we can go to our water tank and basically just increase the maximum water level. But this is maybe not realistic. The right way would be to create rules. So let's create some rules here. I will create 2 new rules. First rule, I will call pump off, which will close my pump when. So here I will select this water tank and I will say if what water level in the tank is higher or equal than 5, then what? Select this pump. So then this pump status will be closed. So if water level in the tank is equal or higher than 5, then pump will be closed. Okay. The second rule will be pump on, which will turn the pump back on. So let's now again select this water tank. Okay. And I will say if water level in the tank is smaller or equal to 1, so we will not allow the pump to go to the water level in the tank to go below 1, then what? In this pump here, the status will be open. So if water level in the tank is equal or lower than 1, then pump status will be back open. Let's click OK. And let's now rerun our hydraulic calculation. Let's go to hydraulic calculation. Again, it will be time simulation of 24 hours. Let's click calculate. Now you can see that we have much less results. Again, we have more than 24 because still something is happening in between. So let's check what. Let's go to time series. And now you can see how our water level in the tank is behaving much more controlled. So we are starting from 3, it reaches up to 5, then it starts dropping until it reaches 1, and then the pump is back on until it's again turned off at this point. Now, if we also add the velocity in this section right after the pump, you can see that during these hours, the pump is closed, and during this hour, the pump is back on. If you need these graphs, you can also draw them to CAD with this icon. So let's click here and let's draw it like this. Or with this icon, you can draw each. Okay, this is all graphs. I don't want this because here I didn't select a tank like this. Now I can draw it like this, so I can see each value on its own graph. Like I said, you can also select multiple values at once. For example, here, let's select this node, this node, this node, and this node. And here, let's select this section, this section, this section, and this section. And now you can analyze it. So these are the pressures in these nodes, and these are the velocities in these sections. You can also here click on this single selection, turn it off, and then you have everything on one single graph. Also, you can go to profile plot graph where you can select some parts of the network. For example, let's go from this node to this node. And this is now basically like a profile. This is a piezometric line, head elevation, but also you can add, let's add maybe the pressures as well. And now you see how the piezometric lines and pressures are behaving during the day. You can also go in time and check how these graphs are changing during the day, or you can switch, for example, let's switch to 4 o'clock, which is our peak flow. Okay, and also you can analyze this with the time dependent labels as well. We can go here to set time function, and now if you click on the arrows, you can see how these temporary labels appear, and you can go through time and check and analyze results also through the labels as well. Let's check this part of the network right after the pump. You can see now the pump is turned off, so the flow is 0. And now when we come to this point, so 7:12, the pump is again turned on and you have the flows. And also if we go to our profile, we can check the dynamic piezometric lines. So check how they are dynamic, they are moving. And for example, when you come to some part of the day that you would like to save and apply, you can apply it. And now these results are applied. So here you have the permanent piezometric lines, you have the permanent label are now applied, and they are now showing our peak flow. And the same is also for our data tables. Let's go to section hydraulics. Let's select, I don't know, maybe this branch. And here you can see that we have our peak flows for our firefighting demand happening at 4 o'clock p.m.